Faraday cage. Electromagnetic fields generated by high voltage transmission line may affect the human health, and national and international standards regulate the alert levels of the electromagnetic field exposure to workers. One of the methods of decreasing the electromagnetic field is the Faraday cage. This is a net made from the grounded conductors placed between the high voltage conductor and the protected area. In this example, we have a single high voltage conductor placed 10 meters above the ground surface, and we have the roof made of steel rods placed 2.5 meters above the ground. The roof is grounded. Our task is to calculate the electric field stress distribution. High voltage conductor potential is 330 kilovolts, which is root mean square line-to-line voltage. As you see, this is essentially a three-dimensional problem. More precisely, it is 2.5-dimensional problem that you can construct in QuickField without the aid of other CAD systems. So let's start QuickField now. In QuickField I create new problem. Cage. Next. Problem type is electrostatics. Model class is three-dimensional extrusion. Length units are meters. Finish. On the left you can see the problem pane, and on the right you can see the geometry model editor window. You can draw plain geometry model here and then extrude it to construct three-dimensional model. So switch to insert mode and draw the cage 6 by 6 meters. Insert shape, rectangle, 6 by 6 meters. Insert. The spacing between rods is 1 meter. So I need to draw the rods. Next we need to assign heights. Switch to select objects mode. Select this area. Follow to the properties and assign levels 0 and 2.5 meter. Then build the mesh and toggle two-dimensional, three-dimensional view. Here you can see the three-dimensional model. Okay, we need to add the space outside and the space above and the high voltage conductor. So I switch back to the two-dimensional view, zoom out, switch to the insert mode and draw the large circle. Okay, for this area, switch to select objects mode, click the area. For this area I assign levels 0 and 50 meters. And I should assign level 50 meters to the internal area too. So select this area and assign level 50 meters. Now let's build the finite element mesh. And again toggle two-dimensional, three-dimensional view. If I hide this large body, I will see the protected area and the cage. The last thing to add is the high voltage conductor. Switch back to the two-dimensional view, switch to insert mode and draw a conductor, for example like this. Switch to select objects and delete these objects. Now I need to select this line and assign the level plus 10 meters. Let's zoom in. Click to select. Hold the control button pressed to select multiple objects at the same time. So for this line I assign level 10 meters. Okay. Now again let's build the finite element mesh and toggle to dimensional three-dimensional view. Now let's select everything and make the bodies transparent. Okay, now you see the cage, you see the high voltage conductor and the air outside. The geometry model is ready, and now we should assign labels. For labels we will specify material properties. Select everything and make it opaque. To assign label you should select the object. So I click here and the face is selected. To select the body I should click the selected face again and the body is selected. And for this body I type in the label name air. Click to select the face, click to select the body behind this face, air. Now let's hide the air blocks. Hide. Well, in fact all other bodies are the air, so I select them all and assign the label air. Now let's hide all bodies but these air blocks under the cage. Select, right click, hide all but this. Now I need to select the edges. These edges are grounded, all of them. And I assign the label grounded. And I need to assign the label grounded to these edges as well. Grounded. In fact, there is a faster way to select these edges. I can use the rubber band. You see, these edges are grounded. And from this side hold the control button pressed to select multiple objects at the same time. Grounded. Now let me check. These are grounded edges. Now let's unhide all and assign label to the ground surface. Again, I will use the rubber band to select the surface and assign the label Earth surface. And the last, I should assign label to the high voltage conductor, but select all bodies, right click, transparent. Now let's rotate and zoom in. And select with the rubber band. This is the high voltage conductor. I assign label high voltage. Okay. Now let's specify physical properties. For the air, I specify electric permittivity, which is 1. For the earth surface, I specify 0 electric potential. For the grounded earths, I specify 0 electric potential. And for the high voltage conductor, I specify electric potential, which is 330 kilovolts. In fact, this is line to line voltage. The line to ground is square. The peak value of the AC voltage is square root of 2 times more. As you see, QuickField allows you to specify some parameters as functions, and you can use x, y, z coordinates in the functions as well. Okay. Model and data are ready, and before I start the analysis, I should build the fine element mesh. You can build mesh in 3 simple steps. First, build the mesh on edges. Then build the mesh on faces. And the last, build the mesh in volumes. Now save all simulation files and run the analysis. The problem has been solved. Let's take a look at the results. Here you can see the electric potential distribution in the air. This is the high voltage conductor. This is the ground surface. Now let's take a look inside. I will hide this block. Zoom in, and I will change the quantity to electric field strength. Now let's adjust the scale. The maximum allowed level of the electric field strength is 10 kilovolts per meter. You can get exact values if you select, for example, some edges and take a look at the XY plot. Switch to the electric field strength. This is at the top and this is at the earth surface. Outside the cage, the electric field strength level increases rapidly and is above the maximum allowed level of 10 kilovolts per meter. You can choose different presentation types. For example, I will switch off the color surfaces, switch off the geometry, and switch on the easy surface plot. And again, let's adjust the range. That is the protected area, and this is the high voltage conductor. Another way to look inside is to use the cut by plane tool. You can change the direction of the cut plane. You can change the position of the cut plane, and you can see the field distribution in a separate window. Well, here it is rotated by 90 degrees. This is the high voltage conductor, and this is the protected area. Here you can build the arbitrary contours. Click any point to start, any point to continue, and get the field distribution along this contour on XY plot, voltage, strength. If you search for the Faraday cage on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures and download the simulation files. Simulation files may be opened and viewed using any QuickField edition, including QuickField Student Edition, that you can download from our website for free.